Hello, drone and geospatial friends. Have you ever wondered how these amazing aerial photos are transformed into 3D models, orthophoto maps, or accurate DEMs? In this comprehensive tutorial, we will thoroughly discuss each step of processing aerial photo data using one of the leading photogrammetry software, Agisoft Metashape. From importing photos to exporting the final product, we will cover everything in detail. Agisoft Metashape, formerly known as Agisoft Photoscan, is a standalone photogrammetry software that allows you to create high-quality geospatial data from aerial images. Let's begin our journey. Important: before diving into the process, the quality of the final output heavily depends on the quality of your input images. Ensure your photos have sufficient overlap, ideally 70 to 80% for forward and lateral. Pay attention to consistent lighting, avoid overly dark shadows or highly reflective surfaces. Also, ensure your photos are sharp and in focus, as blurry images will result in poor reconstruction. Finally, ensure your EXIF data is accurate, especially camera information and GPS coordinates, as Metashape uses them for optimization. The first step is to prepare the data. Ensure all your aerial photos are in one easily accessible folder. It's best to name your photo files in an organized and sequential manner. Open Agisoft Metashape. In the top menu, click on Workflow, then select Add Photos. Navigate to the folder where you saved your aerial photos, then select All Photos and click Open. You will see all your photos appear in the Photos panel. Ensure that your drone camera has recorded GPS information in the photo metadata. This is crucial for georeferencing accuracy. Before processing, let's optimize the settings. Go to Tools, then to Preferences, then to the GPU tab. Ensure all available graphics cards are checked to speed up the computational process. The next step is Agisoft's Align Photos or photo alignment. This is a critical stage where Agisoft will find common points, tie points, between photos and establish the relative positions of the cameras. In the Align Photos window, you will see several important options. Accuracy controls the quality of the alignment. For the best results, use High or Medium. Key point limit and tie point limit control the number of points to be used. For starters, leave the defaults or adjust them according to your computer's specifications. Click OK and let Agisoft do its job. This process may take time depending on the number and resolution of your photos and your computer's specifications. Once completed, you will see a sparse point cloud, which is a collection of 3D points representing the camera's position and objects in the field. After the sparse point cloud is formed, we will build a dense cloud or point cloud. This is a much denser and more detailed collection of 3D points, forming the basis for 3D models and other products. Click on Workflow, then select Build Dense Cloud or Build Point Cloud. In the Build Dense Cloud or Build Point Cloud window, the quality option is very important. Ultra High will produce the best detail, but requires a significant amount of time and computational resources. High or Medium are usually good choices for balancing quality and processing time. Depth filtering helps remove noise and inaccurate points. Click OK and let Agisoft process. Once complete, you will have a much more detailed dense point cloud, providing a rich 3D representation of your project area. You can pan and zoom to view the details. The next step is Build Mesh. A dense cloud is just a collection of points. To create a solid 3D model that can be rendered, we need to build a mesh polygonal surface and then apply textures from the original image. Click on Workflow, then select Build Mesh. In the Build Mesh dialog box, ensure source data is selected from Dense Cloud or Point Cloud. For surface type, Arbitrary is suitable for most 3D objects. However, if you are working on a relatively flat terrain and want to generate a mesh like a DEM, Height field is better. Click OK to start building the mesh. Once the mesh is formed, it's time to add textures. Go to Workflow, then select Build Texture. In the Build Texture window, make sure Source Data is set to Images. Mapping Mode, Generic, is good for most models, and Blending Mode, Mosaic, will provide a smooth texture blend between images. Then, click OK. After this process is complete, your 3D model will appear with realistic textures in the model view, ready for visualization. For aerial mapping projects, the main goal is often to generate orthomosaic maps and digital elevation models. Let's start with the DEM. Click on Workflow, then select Build DEM. In the Build DEM dialog box, for source data, you can choose Dense Cloud or Mesh. Generally, using Mesh produces a smoother DEM. Make sure you select the correct projection or coordinate system for your project area, such as WGS 84, UTM zone, etc. Also set the desired resolution or GSD for your DEM. Leave it at the default if you don't want to complicate things. Click OK. Once completed, you will see the digital elevation model of your survey area. Finally, we will create an orthomosaic, a geometrically accurate image map. Click on Workflow, then select Build Orthomosaic. In the Build Orthomosaic dialog box, make sure Surface is selected from the DEM we just built. Blending mode, Mosaic Default, is usually the best choice. Adjust the projection to match your DEM and set the resolution or GSD you want for the orthomosaic. Leave it at the default if you don't want to complicate things. Click OK. Once we have all the main geospatial products, such as the dense cloud, 3D model, DEM, and orthomosaic built, it's time to export them for use outside of Agisoft Metashape, such as in GIS software or for project reports. To export your digital elevation model, or DEM, go to the File, Export menu, then select Export DEM. In the Export window, the most recommended format is GeoTIFF. This is an industry-standard format that ensures your spatial data remains properly referenced when opened in other GIS software. You can also set the output resolution or coordinate system if needed. After that, click Save and specify the location where you want your file to be saved. Next, let's export the orthomosaic that we have created. Go to File, Export, then select Export Orthomosaic. Similar to DEM, GeoTIFF is the best choice for GIS integration. However, you also have the option to export it in common image formats like JPEG or plain TIFF if the purpose is only visual. You can adjust the compression quality to save file size. Click Save and choose where you want to save it. If you plan to use the dense point cloud for further analysis or the 3D mesh model for visualization, you can also export it. For point clouds, select File, Export, then Export Dense Cloud, with popular formats such as LAS or PLY. As for textured 3D models, use File, Export, then Export Model, and choose a format such as OBJ or FBX. In addition to geospatial data, Agisoft Metashape can also generate comprehensive project reports. These reports are very useful for documentation or for sharing processing details with clients or colleagues. Go to File, Export, and then select Generate Report. Here, you can choose what elements you want to include in the report, such as camera details, accuracy statistics, and processing summary. Click Generate and save your report in PDF format. That's it! We've successfully completed the entire workflow for processing aerial photo data in Agisoft Metashape. From raw photos, we've produced a sparse cloud, dense cloud, textured 3D model, DEM, and accurate orthomosaic. If this tutorial was helpful, don't forget to like, leave your comments below, and subscribe. Thank you for watching, and see you in the next video.